In this video, we're going to put everything together that we've learned in the previous lessons from this chapter on roots and powers. We're going to apply our exponent laws that we talked about last video. We're also going to use the concepts that we learned on negative exponents and fractional exponents, and also from changing fractional exponents into radical expressions. So all those things we're going to put to use in these examples that we're going to go over today. So looking at example number 1, we have an expression here. There's a couple different ways you could approach this. What we're going to do here first is we're going to simplify what's inside the brackets first. So I'm going to look at the bases of a first. So we have an a to the 6 on top and an a to the 5 in the denominator. We know when we're dividing, we subtract the exponents. So 6 subtract 5 is just going to be equal to 1. So we're going to have a to the 1. You don't have to write 1. And then b9 over b8, same thing. 9 subtract 8 is just 1. So we have b. So it's just ab or a1, b1. And then that's to the exponent of negative 2. And again, we can kind of envision this being over 1. So now what we want to do is get rid of that negative exponent. So in order to get rid of the negative exponent, we take the reciprocal of our expression. So we're going to flip this expression and it becomes 1 over AB. And now our expression is equal to, fix this. Okay, now our expression has an exponent of positive 2 because we've taken the reciprocal. We can now apply the exponent to both the numerator and the denominator. So we'll be left with 1 squared over a squared b squared. So again, be careful with that. That's one of the exponent laws that we learned, right? So a power of a product. So we have to apply that exponent of 2 to both the a and the b. So in the question, we were given the fact that a was equal to negative 3 and b was equal to 2. So we're going to have 1 over negative 3. We'll substitute the negative 3 in for a. So negative 3 squared multiplied by our 2 squared, which is our b. So then we have negative 3 squared is 9 and 2 squared is 4. So in the denominator we're going to have 9 times 4, which is just equal to 36. So our answer is 1 over 36. Example 2. So here in example 2 we have a bunch of fractional exponents. We're going to try and do some simplifying inside the brackets before we apply that exponent of 6 to the whole thing. So let's look closely at the bottom here. So we have 7 to the exponent 1/3 and 7 to the exponent of 5/3. So when we multiply with the same base, we can add the exponents. In this case, our exponents are fractional, right? And we know how to add fractions. So in order to add fractions, we have to add the numerators, and then we leave the denominator the same. So I'm going to rewrite this. So on the top, we're still going to have 7 to 2/3. On the bottom, 1/3 plus 5/3 is equal to 6/3. So we'll have 7 to the 6/3. Okay, and yes, technically that's equal to 2, but it's going to help us here in a second to leave it with the denominator of 3. Because as you can see in the numerator, we have 7 to the exponent of 2/3. And we know when we're dividing bases that are the same, we need to subtract the exponents. And in order to subtract fractions, again, we need to have a common denominator. So that's why I'm leaving it as 6 over 3 as opposed to 2. So when we do that, what's 2/3 subtract 6/3? That's going to be negative 4/3. So we'll be left with negative 7 to the exponent negative 4/3 to the exponent of 6. And so now we can just apply our power of a power exponent law. So we can multiply. This is just the same thing as 6 over 1. So negative 4 over 3 multiplied by 6 over 1 is going to be equal to negative 24 over 3, which we know is just equal to what? Well, it's equal to negative 8, and all of that is over 1. In this example, I mean, sometimes they ask for an answer, and a lot of times they just want you to simplify by writing as a single power. But again, we want to eliminate that negative exponent. So in order to get rid of the negative exponent, we can take the reciprocal, and that will change the exponent to make it positive. If we want to, depending on what the question asks, we can evaluate that even further, and we can write the actual answer to 7 exponent 8. Example number 3. So for example number 3, this is a very common type of question that you'll see. We have an x and a y, so we have two variables. And what you want to do is you want to focus on the bases that are the same first. So we're going to focus on the x's. And because we're multiplying here, so we have x cubed y squared multiplied by x squared y to the negative 4, we're going to apply the exponent law of when we multiply with the same bases, we add the exponents. So we'll look at the x term first. So then we just look at the exponents and we add them. So 3 plus 2 is equal to 5. And then we look at the y. 2 plus negative 4 is equal to negative 2. Do we want to leave it like that? No, we do not. We want to move the term that has a negative exponent to the denominator, which will change the exponent and make it positive. So this expression will then just become x to the exponent 5 over y squared. And that's our final answer. Again, you're only moving the value or part of the expression that has a negative exponent to make it positive. All right, example number 4. We have 8a cubed b 6 to the exponent of 1/3. So again, this is a power of a product. So we need to apply that 1/3 to each of the terms inside the brackets, including the coefficient. So we have 8 to the 1/3 multiplied by, and then we have multiplied by a. So then we have power of a power. We have to multiply the exponent of 3 by the 1/3. So 3 times 1/3 is equal to just 1. So we just have a. And then we have the exponent for b as 6. So we have to multiply the 6 by the 1/3. When we multiply 6 by 1/3, we get 2. So we have b squared. And we're almost done here, but we can simplify it this first part. So we know that a to the exponent of 1/3 is the same thing as the cube root of 8. And we know that the cube root of 8 is equal to 2. So then that leaves us 2ab squared. And finally, we have one last example. Let's again evaluate what's inside the brackets before we deal with the exponent to the 1/2 for the whole thing. So let's look at the coefficients first. So 100 divided by 25, that's equal to 4. Then we look at the a's. Okay, so that we have an a in the numerator, which is we know is a to the exponent 1. It's just an imaginary 1 that's there. Then we, again, when we're dividing, we subtract the exponents when we have the same base. So 1 subtract 5 is equal to -4. So we'll have a to the -4. And then b, well, we could imagine, show you a little trick here, b to the exponent of 0 in the numerator, right? We know that anything to the exponent of 0 is just 1, right? So that's why we can do that. So if we then look at the b's, and we do 0, subtract -1/2, that's the same thing as adding 1/2, that will give us b to the 1/2. And all of this is to the exponent of 1/2. So now we're left with something that we had in the last question. So we have a power of a product again, so we have to apply that 1/2 to every single part of what's inside the brackets. So we have 4 to the 1/2. Then we have a -4 to the power of 1/2, so we have to multiply those exponents together. So what is -4 multiplied by 1/2, or half of -4? That would be -2. And then we have b, what's 1/2 multiplied by 1/2? Again, you multiply the numerators and multiply the denominators when you're multiplying fractions. So we get 1/4. And now we can just simplify this a little bit more. We know that 4 to the exponent of 1/2 is the same thing as the square root of 4, which we know is equal to 2. So 2a -2b to the 1/4. And then one final step, we see that we have a negative exponent. We don't want to have a negative exponent, so we're going to move the a part of it to the denominator. So we'll have 2b to 1/4 all over a squared. And depending, again, what your question specifies the answer to be in, you could change that to the 4th root of b all over a squared. And that's your answer.